Did you work it out? Yeah?
Just giving.
It's blank?
You just want the XML file.
Yeah, well, this is a matter of the file browser, of the Windows Explorer in this case. Do you have a Firefox browser installed here?
No, there's apparently like in Christian's machines.
Yeah. Is there a Firefox installed? This is not a matter of OPALS, but it's just a matter of whether the SVG file could be, let's say, successful.
Just try right-clicking on the SVG file. Does that open another? Stick on a run stick, I'll open it on my Mac. Just stick it in that.
I had a separate problem.
Okay. But you...
Yeah, I opened it with Google Chrome.
Okay, Google Chrome, yeah? Do you have a Google Chrome installation? Apparently there's a problem with visualizing the SVG contents in at least some of the installed Internet Explorers. Which is then not a problem for PALS, but for Internet Explorer. But anyway, if you have any additional Internet browsers like Firefox or Chrome, then try it out with a different browser. Well, this depends on the sample range of our... Well, there was a question. Yeah? How would we, coming back to the, if we want to visualize the, or do a histogram of the echo width, come about the, a reasonable data range. In this case, I would propose the following strategy. I would run the command without any of these additional parameters, like choose the ODM file and choose my, in this case it is underline echo width. It is not case sensitive, so. And it would just run it like that. It doesn't contain an attribute echo width. I thought it was echo width.
No, without the underscore.
It was without, thank you. Otherwise I would have asked the info module what the proper name was, but you know it. And you are right. Great, thanks about that. And you find that the actual data range is between 0 and, let's say, 40. Yeah? And our standard deviation is something like 1. The median is 4. So I would run it probably between, if you want to specify, well, we can have a look at it. Probably the histogram is reasonable as it is. In this case, it isn't. So I would restrict it between something like 3 and 10 with a bin width of 0.5, something like that. So it would be then sample range between 3 and 10, and the bin width would be 0.5. And running this command would give me an histogram like that. So everything beyond 10 would be in the overflow class, which is drawn in red. You can see it here because it's too tiny, right? If you would restrict it to 7, then you would see it. Let's do this. Or I do it. You don't have to do it yourself. Do 7. Now you see it very clearly. Okay?
Can you output the plots to PDF? Do you have to use SVG? Or can you...
To create a PDF, I would let's say print this to a PDF printer.
Okay.
There's no direct PDF output for the space.
Something Adobe Illustrator, you can edit this and save as a PDF.
Yeah. I use Matplotlib, so that just goes straight to PDF.
Yes.
So
Yeah.
that's sometimes easier.
And we used the Boost Plotlib, and
Okay.
this is creating SVG.
Okay.
That's the real. Okay, let's go back to our. I think I need to hurry up to be able to hand over to Lothar. What else is done here is we had one gridder already in our portfolio, which is the interpolation module. The interpolation module is kind of different from the rasterization module, which is called OPALS cell. What is the difference? OPALS cell strictly has a look at the raster cell and nothing beyond. Whereas grid takes the point and has a, let's say, certain neighborhood defined by the number of neighbors. And I think Lothar will go into details concerning that. But cell only looks at the very, very cell. All the data points within the cell are, let's say, taken into consideration. And in this case, but apart from that, both transform the point cloud into a 2D raster, right? So cell takes the input, creates an output for the amplitude. We already know this how this works. We specify the attribute amplitude, otherwise it would use the heights, right? Same story here. The cell size is 1 meter, and for the cell module we have to specify which feature do we have, and a certain, let's say, an entire list of features is provided, like the minimum, the maximum, a quantile, the so and so quantile, the median, the majority, the minority, whatsoever. There are a couple of let's say statistical operators. In this case, we're interested in the maximum amplitude within a 1 by 1 meter cell, and then we do a colorization of this with using set color. We have already discussed the set color module, and then we basically do the same for the echo width, right? In this case, we specify the attribute echo width with a cell size of 1, and again we choose the highest value, the highest echo width value which within one cell, and then we're doing a colorization. In this case, with, let's say, user-defined palette file. It's the color brewer palette from again, it's not so important, with a certain interval, and the same for the echo width. So I would suggest that we just run this command. What was it? It was underline fwf attributes.but. Coming back to Pete's presentation, it's always good practice to store your commands in a shell script or a batch file in this case. Then you have a proper and nice let's say, documentation of your parameters, and the rest, as I said, can be found in the log file. So, last thing from my side, I just want you to open QGIS. It is still open in my case, and drag in the new products which we created. This is the SB Max Echo Width and a set coloring of it. Okay, and we do the same for the SB Max Amplitude underline set coloring, right?
So was this XML file, the log file, was it overwritten now when you run the script again, or does it just update the...
I'll just show it, yeah? Okay, let me load it first. There was a question, what is with, you mean the OPALS log file?
Yes.
If you open it, you see that we have now 24 runs, right? So it is simply a consecutive logging of all our commands. I'll leave it here. We started by typing import info grid, shade, set coloring, and we did the thing with the filtering, with the set filtering, right? Then we switched over to the full waveform attribute analysis. This is where the histo commands came into play. Must be around here. We had several histo commands from here, and then we started the script all over. So it started here by 18 in my case, with the import statement. This is the histogram code for the amplitudes, the cell code for the amplitudes, the set color for the amplitudes, and then we have 3 remaining commands, the same thing for the echo width. And this is basically what was in our script, right? It's the last 7 commands. 7 commands from the... yeah. And now we have, if we go back to the QGIS, we have now a representation of, well, I only have visualized now the amplitudes, and what we see here is a color coding of the amplitudes. Or to be more precise, a rasterization, and we always choose the highest amplitude within a 1 by 1 meter cell. And the darker it is, the more backscatter we have, and we clearly see the pathways in here. They are gravel, and gravel has a high backscatter, so we nicely see the pathways in here. Apparently some parts of the roof have all high backscatter, and here in the courtyard as well. Whereas the meadows in here, the gravel, again here, this is gravel path. Gravel, I think it is. Gravel or gravel? Gravel. Gravel. This is meadows. Here we have the shrub kind of vegetation with rather lower backscatter, and I think you got the message already.
This would be similar to the intensity.
Similar to the density.
And intensity.
Similar to the intensity. Yes. Basically, the difference between the intensity and the amplitude is the peak power, whereas intensity is the area below the entire waveform.
Okay.
Right? So to put this right. Yes, this is
similar, but that's the difference.
The broader the peak and the higher it is, the higher the intensity, but you can have also a very narrow peak with a high amplitude, then the intensity would be lower, but the amplitude will still be the same. Right? And then, before handing over to Lothar, having a look at the colorization of the echo width, which appears in yellow, where we have low echo width, and low echo width basically means we are hitting hard surfaces, so we don't have a high height distribution within the footprint, which is recognized as 1 echo. Echo width is always high if we have a height spread within the footprint of 1 echo, which is often the case in vegetation. So echo width is a good separator between especially low vegetation and ground. Often it is not the problem to distinguish between high vegetation and ground, because we have a high offset, a high, what you call height, yeah? What we call normalized height, anyway, yeah? Height above ground. Whereas it gets hard when we are near to the ground, but the echo width helps, as we can see here. So we have higher tones in the shrub type of vegetation in here, whereas we have, let's say, homogeneous. We don't see the paths here. Of course, we don't see them because they are, let's say, hard, not concrete, but still hard surfaces compared to this, let's say, shrub type, where we mix the echo between the ground and the top layer of the shrub, right? Having said that, I want to hand over to Lothar for the. Thank you.
Welcome everybody, thank you Gottfried. So he trained you to experts, now we'll do the exam. Please take out a piece of paper and pencil, I'm just kidding. In the next couple of minutes we will talk about processing local attributes coming from neighborhood of points. So Gottfried showed like how to visualize points, how to visualize attributes which directly correspond to points. But now we try to figure out the local vicinity of points and try to get out some information of this local vicinity. So give me just 1 second to clean up here a little bit. To get back to the presentation if it's still there.